Hello everyone, I welcome you to Lithuania Pi. It's nice to be here. I'd like to start off by thanking Edvardas and Edvardas for organizing and hosting this event, because I'd really love to see the Python community grow in Lithuania. So I hope you find today's topics, useful and the whole experience fun. So a bit about me from the start. I've come across Python in high school, so now that's more than 10 years ago. Coming from Free Pascal and C++ in school, the flexibility and freedoms of Python instantly kind of captivated me. And since then, it was my go-to choice. So currently, speaking about professional experience, I have around 3 years because I was not always in the IT field. I teach Python on the weekends in Software Development Academy, and I'm a senior Python developer at PVCase in Cone. So, about today, I'll be speaking about web application deployment in the cloud. We'll take a Flask application and using Zappa command line tool, deploy it to Amazon Web Services on AWS Lambda and API Gateway, while discussing the pros and cons of serverless along the way. So let's get to it. Python in the clouds. When speaking about web development, in the early days, you didn't have much options for deploying your websites that you code in Python on, let's say, shared hosting, because the usual shared hosting services would only offer basically the LAMP stack, Linux, Apache, MySQL, PHP, and you would rarely come up on a shared hosting that would offer a mode WSGI, which allowed you to kind of host Python websites. And through the years, that has changed as services developed, let's say, software as a service, and before that, containerization, where you can put your applications in a container, be it Docker, Heroku, and you can deploy your applications as a container. So that basically unlocked your hands to use any technology you want. And currently, at least I have mostly experience with AWS, and it has really nice integration with Python itself. You could actually, if you're using AWS Lambda, for simple functions that, let's say, don't have to do with web applications, but have to do with file processing or event-driven software, you can just code them in the web browser and deploy them straight away. So what does serverless mean in this context of web applications? Most of the time, it's a pay-per-use billing model. So that means you don't have a running server 24/7. You don't need to pay for that, but you do have to pay when your service gets used. So in the context of web applications, as soon as you have a visitor, the application serves a request. He does additional, let's say, requests to get static files and everything, and you get billed accordingly for the services that you use. It also offers out-of-the-box scaling. So we'll see when I'll show you AWS Lambda. AVS has regions. So I'm going to demonstrate on EU West 1, which is Ireland region. By default, it has a limit of 1,000 concurrent Lambda functions at a single time. You can always request Amazon for additional resources, but that's the default you get. So when running an application on AWS Lambda and someone visits your website, basically if concurrent calls are made and your Lambda hasn't finished working on a request it previously received, but received another request, AWS will scale the amount of Lambda functions and distribute the work accordingly. So you get scaling without actually managing any infrastructure. And That's very cost effective for websites that have a volatile load pattern. Let's say you have peak time loads at some hour, and previously you would have to kind of scale your servers to handle peak time. And when you don't have the peak time, they would just sit idle. So that's not very effective from a cost perspective. And as I mentioned, it's minimal maintenance and supervision. So the tools are very mature and it's quite easy to use them, as you'll see. So about AWS Lambda, if we're talking about price, the requests cost 20 cents USD per 1 million requests of the Lambda function. So you can expect that's quite cheap. Now, additional cost is duration, 4 gigabyte seconds. And how you understand that is you allocate RAM memory to it. You can allocate from 128 megabytes to 3000. And depending on the time your function works, it will count the time and the gigabytes used. And that will transform into gigabyte seconds, and you'll be paying for it accordingly. The time is rounded up to the nearest 100 milliseconds. So if your function, let's say, is very quick to complete the request, like 6 milliseconds, 10 milliseconds, you'll still get billed for 100 milliseconds. But that's not an issue because when you have these calls, you know, as soon as the call is over and you have like 5 minutes idle time, you've already made up for it if you, let's say, had a dedicated instance running. So one thing to note, compute power is also allocated proportionally to the memory, although the allocation isn't of a linear fashion. And what you discover is if you go above 1.5 gigabytes of RAM, you would start to have 2 processors allocated on the Lambda function. And you should be aware of that if you were deploying an application that only utilizes 1 processor. Most of the time, you don't have to go that high. And it's always about finding the sweet spot. Let's say you want to stay beneath 100 milliseconds. So you would get billed for the 100 and not overpay for the gigabyte seconds. You can also configure a timer on the function. Let's say if you have some calls that might hang or something, you can protect yourself for being overbilled by telling that this Lambda function should take more than 1 second or 15 minutes. 15 minutes is the max a single Lambda function could run. So if you wanted to go beyond, but that doesn't go for web applications, you would have to chain them. About language support, it currently supports Python, .NET, Go, Java, Ruby, Node.js, and it actually implemented custom support where you can provide bootstrap scripts now. So basically, if you want to test any other language like Rust or something, you know, exotic, you might go for that. Just make your bootstrap scripts and upload them to the Lambda function. So is serverless actually that cheap? You know, 20 cents per 1 million requests. And that's not completely the case because it depends on what you're using. You'll have to use additional services for some functionality. So let's say if I want a Lambda function that takes HTTP requests, I'll have to expose it through a URL. And to do that, I have to use AWS Gateway, API Gateway. That has a cost basically of $1.11 in the Ireland region for 1 million requests, plus extra if you enable caching of requests. So next, if you want to attach a custom domain, you'll have to pay 50 cents per month for the domain. It's called the hosted zone, where you add the domain records, and an additional 40 cents per 1 million requests. And also, as you'll be attaching to that domain, you'll have to create a custom domain name in AWS API Gateway, which will create a CloudFront distribution. And that costs $1.20 per 1 million users. So if you add them up, it's around $3 something per 1 million calls. And you also have to think about your static files, let's say, because as soon as someone visits your website, you know, they might actually make another 10 calls to get your CSS files, JavaScript files, and everything, although that will be cached and subsequent requests won't download them, right? Of course, there's also the database. So if you want to go for basically serverless type of database, you would probably lean towards DynamoDB on-demand mode. On-demand mode also means that it manages the scalability by itself. You just pay for the reads and writes that occur on the database. So if no reads and writes occur, you don't pay anything, just basically for the storage of the database. The gigabytes cost cents. So, as you can see, reads are around 30 cents per 1 million requests, and writes are $1.40. So now talking about the framework, there are multiple tools to work with AWS Lambda and deploy Python applications. One is, let's say, AWS SAM, which is serverless model, something, but it uses its own language syntax and setup, and I didn't find it that much convenient. The other would be Chalice, which is also managed by and developed by AWS team. It looks a bit like Flask, but basically what I don't like about it is that you get vendor locked. If you have a Flask application, you have a Flask application, and you can basically deploy it any way you want. But if you use Chalice, it's already leaning everything towards AWS services. So if you want to migrate to another cloud provider, you'd have to rewrite it, basically. And Zappa is a tool written in Python and manages the deployment to AWS Lambda, and might be just as easy as going inside your Flask application, activating your virtual environment, installing Zappa framework, telling to initialize, you get to pick some selections, and then Zappa deploy. And your function will be deployed on AWS. And I'll show later how to attach, let's say, a custom domain name. Now, for Flask, most of you, if you've been done at least some tinkering with web development in Python, you should have already encountered the Flask micro framework. It's very nice when you want to start fresh and don't really know what you're going to use. So it's extendable by installing plugins. But in the start, if you don't need something, you just don't have it, right? And as you see, a simple hello world application, which serves the text hello world on your base directory on the URL, is just 5 lines of code. And then you would just tell it in the terminal so that your entry file is hello Python, and tell it Flask run. Now, the templating language, in Flask, by default, you get Jinja 2 language. Templating languages are for processing HTML text with special syntax so that it would generate dynamic HTML, inserting the values that you specify in your file. So it has a context. You send it values that this is my value, and inside the HTML file, you write the code to actually use those values and generate, let's say, paragraphs, objects, a list in the table, listing elements. And why I choose, most of the time I use Mako, because it has more freedom than the alternative Jinja or, let's say, Django templating language. You can use any Python syntax that is valid and access system functions. Basically, you're not limited, whereas Jinja kind of limits what you can use from Python inside the templates. And in Django, you'd have to write special functions to expose them in the template. And you can see in the example, all you need to do is import template class from Mako template. When it's integrated into Flask, it's even a bit different. You install Flask Mako and kind of inject it into the application. But the basic idea is this: you have a string, you say, I'll have a data variable inserted into this place, and then when you call render, you pass it that date will be equals to world. That way you render the text with inserting the value you pass to. And you can see you can use if statements, loops, everything. And now I think it's time I get to coding. So I'll finish here. Let's see. I have a small application for the start. This is the basic hello world, and you can see that if I start it, all I have is this, right? So once you have a Flask application like this, remember what you need to do. You'd say pip install Zappa, and I think I already have it. Yes, it's already satisfied. So I do Zappa init. It says which environment do you want to name it. A bucket on S3 will create for you for storing the files. It's going to basically package where it finds your application entry point. So this is the app. That's why it says app. Then this is an interesting one because it asks you if you would like to deploy this application globally. And as I said, AWS has kind of defaults per region. So I'll be working in Ireland region, but you can deploy your application through the whole world. And you can imagine it will be have a really good latency because according to where the customer is that's calling the website, it will call the endpoint closest to that location. So currently, no. And I see it generated a Zappa settings file. So I say everything's fine. And I tell it Zappa deploy dev. Before this, you would have to set up your AWS CLI and configure an API key. As I have already done that, you don't really see it in the step, and as a default, it goes to my AWS folder and searches for default profile credentials. Thus, it's already connected to my AWS account, and it deployed the function. So now I have a publicly accessible link, which has my function there. So if I change anything here, maybe I'll want to actually render some HTML. I'll create a directory. It's called templates. That's the default directory you want to have your templates in, and that's the one that Flask looks for by default. I'll say HTML file and index. Call it index title 25. Let's say H1. Now I go back to my application. What I would do is I would get render templates. Render template. I would go, instead of saying hello world, I would give it render template, say index HTML. Oops, HTML. We can track locally. You check if it's working. Okay, it is. And then what you do is you just go Zappa update dev. Now, this seems easy, right? Because that's the application is quite small, and in real applications you'll have more dependencies, more packages, and everything, and you might run into some various, issues because sometimes the Lambda functions don't accept the packages as is, and then you would have to go to AWS, launch an instance with the Amazon Lambda image, compile your package there on that image so it would be compatible with Lambda functions, and then push it into the file. So there are some things you have to do. And I should also mention that the compressed file, which is being loaded into the Lambda function, is currently limited to 15 megabytes. But if it goes beyond that, Zappa supports lean deployment. That means it zips your application, it uploads it to S3 storage, and then once the Lambda function launches, it has a temporary storage of 500 megabytes it can access. So what you do is you download the application from your S3 folder to the temp storage and import it from there. So it goes into memory. Then it runs as it would. And another thing to mention that these Lambda functions, although they execute for less than, let's say, 100 milliseconds, they still keep running. And we could actually see that if I created a global variable inside, and this we'll use later on. I'll show you how to deploy a Flask admin instance. Again, serverless. Okay, so what I want to show you is how it actually survives after it finishes the call. State, let's call it keep state. I'll just keep it a string. And I'll say that I want a new endpoint, which takes in a name. And I'll say name here. I'll say global keep state equals name, and pass it index. I want to actually pass it like this. Oh, I could actually show you Mako templates as well. So to do that, I would install Flask. So if I want to enable that, I do from Flask Mako import Mako templates. Then I do Mako templates, takes in the app, injects all it needs into it, and I use a render template from this one. Then what I would do is I would call, let's say I do this state HTML, and I would say welcome to 25. Let's get a paragraph element and say we have a previous state, and current state. Okay, so like that, I would go here, say state. I want to take the previous state, I'll get previous equals state, previous, then current state will be name, and we can test it out locally. All right, I didn't change the name of the function, so this is state page. Okay, I'll launch it again. Go here, I say columns, previous state is columns, and if I say blah, it goes like this. And if I do it again, it should go Edvardas, right? Okay, so that works. And if I deploy it to our function, go like this. Now the question is, will I be able when it has the dev inside the name? Yes, it is. Yeah. So what you can use this for is actually for local caching inside the Lambda function. If you want to cache some response, let's say for 5 minutes or so, you could actually make a dictionary where you cache results you got from the database and only refresh them if they expire. That way you implement kind of local caching without using any other AWS options you have to pay for. So this is that, and probably a website like that is not that impressive. So I'm going to quit this one and go to, this is a Flask admin application. Basically, I downloaded it from GitHub. Let's see. PyCharm projects. This was the Flask admin master. So if we launch it, it looks like this. Now login, you have admin, and you have this awesome dashboard. Okay, so same goes here, right? I think I have stuff already. Yeah, def, that's fine. Good to go. So deploy def. Oh, I've already deployed it. Okay, so what did, let me get the link. Sorry. What did the, oh, actually, I'll show you where it's, where's the source of it. If you go to CloudFormation, what Zappa does, it creates CloudFormation templates. So it gets deployed here. And let me see, updates. Just waiting. You can see this one waits in at 25 megabytes because it has the static files with it. You would optimally use, oh, and I got an exception, valid parameter. And did I type something in while I was clicking around? Type, REST API. Oh, it actually doesn't. Okay. So on the spy, let's call it 2 and see if it goes well. It seems like the templates are off a bit. So we'll just create a new one. Yeah, so what you want to do most of the time is move your static files to S3 service, and you can create, tell it that this bucket will be a website. So you don't have to handle and serve static files from Python Flask. That's what you usually want. There you go, deploying to API gateway. There we have it. And you can see it's here. There we go. And now you can see that it tried to do the admin when it actually has the dev inside it. So it broke it. You would have to go around these issues by setting different, let's say, you could pass the URLs from an environment variable, which you can set in AWS Lambda, but now we're going to resolve it by just attaching it to a real domain name. So I'll go into API gateway. Let's see the APIs I have. Colonus by 2. I have a custom domain name ready, called Lithuania by, and I'll tell it to map to this application dev environment. So now, if I go to right, did I set up? Right. What I forgot is Route 53. Route 53, API gateway is this one. I'll actually copy the name. Yeah, this is the dashboard. Yep. And to allow it to access, I have to tell it, just Lithuania. It will be an alias of CloudFront distribution. This from API Gateway. I create the record in the DNS records, and let's see how fast it will refresh it. By the way, we'll soon have a load test for it. I'll show you a bit. Let's see. Spawn more workers. I have a compute instance set up on AWS, which has 16 cores, and I'll launch requests against the function. But Lithuania, did I get the URL incorrectly, or did I not save the mapping? Dev path9. Let me check. This is the demo gods. Always when you do a demonstration, something must go wrong. Is this the one? Or, yeah, this is the admin one. Okay, Baltūsis. Oh, I'll save before I can from the get-go. Domain names. Lithuania. Distribution is fine. So, wait, is it a regional? Oh, no, edge optimized. Okay. Dev path should be good. So, well, sorry. I hope I didn't make just a typo, but no, doesn't want to.
No, everything's all right, you know.
Yeah, okay.
Sometimes that happens. Nobody's safe from that.
Yeah, the interesting thing is I tested this today to make sure it works, but I see that it didn't go still as planned. Okay,
you know,
so
it's Murphy's Law. You can't do anything about it.
Okay, so what we'll do is we'll just go and fire at the serverless dev function. This is the simple one, so it has least overhead, let's say, and you can see this is the one that tells welcome Lithuania Pi. So I give it this link, and as I said, I have locus deployed, and I'm going to go with a link, let's say 10,000 user simulation. What this does is it simulates a user visiting randomly between 1 and 3 seconds. So they should equal out to 3,000 requests per second. And the hatch rate is 100 users at a time. So,
sorry to interrupt you, Edvardas.
yes.
There are some people suggesting some options. What could have might went wrong.
Let me see.
Yeah, you can just click on the chat and you'll be able to see, you know, what people texted, or if you want, I can read it out loud.
Yeah,
so
you can try.
Yeah. So the first suggestion came from Edvardas. He says that alias had comma at the end. Don't know if it's supposed to be there. And another suggestion is from Matos, maybe HTTP instead of HTTPS.
HTTP where? Here you don't even specify, you just specify the distribution, and as it kind of is an auto select, that dot, oh, maybe it's not, maybe let's see. Yeah, maybe I added a dot there, actually. Good catch, if that works. And, no, not yet. If you want to try HTTP, as it has an SSL certificate attached, automatically redirects it. But it might be something wrong with API gateway. Okay. No, so I'm not really sure at the moment.
That is totally okay. I mean, you know, thank you, Edvardas and Matas, for the suggestions. You know, it's okay. Not a big deal.
Yeah, so back to the load testing. Locust is now running on an AWS instance. I'll show you. This is running instance. I've connected to it through SSH. You can see it's hatching users distributedly. And it has 32 CPUs, which are 16 real CPUs because it uses hyperthreading. So once you launch it, it's still running. It's already hashed all the users, and you can see that the requests are coming in at around 5,000 users per second. And the current response time is around 20 milliseconds, 29. So that's the scalability I was talking about. And basically, if you wanted to hit the limits, let's try 30,000, because there's a hard cap on API gateway. If you saw when I clicked on throttling, APIs, doesn't matter. This is Colonus. No, I don't want this one. I want the serverless. This is the simple one. And you can see the rate is 10,000 requests, and it disables the bursts. So it was actually limiting the burst to 5,000. Maybe that was, okay, now it's going up. But you can see that the response time isn't really drastically increasing. So with a few, let's say, lines of code and a few lines for deploying your application, this is the scalability that you basically get for your function. So if you have peak time traffic, you can see that it shouldn't be a problem. And if you need more than 10,000 requests per second, you would just need to request AWS to raise your limits. So I think that will be it for me. Oh, we can see it's rising a bit, but yeah, I'll stop it there.
All right, so Edvardas, thank you. You know, we all know that we run into some problems each day, and you know, it's totally fine. Don't worry about it. And you know, what I'm happy to see is that you also have some solutions that could potentially fix this. Unfortunately, you know, we have some limited time, and you know, if all of the attendees have any questions, we can go ahead and, you know, you can start asking them right now. We have 15 to 20 minutes for that, and we will move on to the next presentation.
Yeah, I can actually see the chat now once I've disabled the screen share.
Probably due to the screen share, you were not able, you know, to see what were people typing. So. Okay, so we have the first question, and it says, how do you clear the global cache?
Yes, that is what you have to look out for, because there is no real way. There's no real way to clear the whole cache, because it might appear on a random instance when the website is under high load. So if you're looking for consistency, don't use the cache on the Lambda function. How do you manage Redis and Celery on AWS? Well, you can run Celery on a separate, at least in my previous work space, we used to run it on an EC2 instance, and Redis was hosted from AWS as a prepared solution. So you can launch a Redis instance, just you have to pay for it when you're not doing it yourself. And Celery, Yeah, just EC2 instance, you expose the IP, you can attach the IP to Route 53 to a domain, and that's basically it. Managing, you usually go through, connect to your instance through SSH and do what you need there. What would be the typical continuous deployment pipeline? Well, as you saw, you can have stages. You can name it dev, staging, production environment, and basically from the branches you have to use different settings files, or not forget which stage you're deploying to. But I think you could set it up on AWS code build, just that we didn't really use Python to that extent to deploy it for code deployment. Does it conflict? Well, it is just an abstraction of CloudFormation, which is what Terraform or Ansible, no, Ansible though, you created, no, Terraform I think still uses CloudFormation. But yeah, Zappa is just an abstraction on top of CloudFormation, so the templates would conflict with each other because one would try to override the other, I guess, if you give them the same stack name. So you have to decide on what you use. If Zappa is not enough for some features, you should go on to making your own custom CloudFormation templates. You can use the software development kit, which is kind of the latest abstraction from AWS for that, or just other software like Terraform.
Go ahead.
It's not, that's what you have to decide basically. It depends on your website. If you have, you don't have any peak traffic or anything, which is probably what you will have when you're using a shared hosting for €5 a month, which handles the load. So it all depends on the visits. You would have to test basically if it goes beyond that once you have it deployed on Lambda, or if it's not, because there is some threshold in which it's more convenient for you to start up your dedicated instance and not use AWS Lambda, especially if you have very consistent load, like let's say messages or inputs coming in from Internet of Things or everything, where you know the amount of traffic you have to serve. So yeah, it's always negotiation. So you have to see at which threshold it's better for you to step out of AWS Lambda to a dedicated service. And another note, you can't use async in AWS Lambda. So it's not like it can send you 5 requests to handle in a single Lambda execution. It handles them sequentially. So you can't really use the benefits of current async frameworks of Python.
All right, so I guess we still have a minute or two for more questions. If there are no more questions, then I will say again a big thank you to Edvardas for this great presentation. I have been recording it, so we will see how is the quality of the recording, and we will decide, if we want to upload it or not somewhere. And moving forward, we have our second speaker today.